In this video, we're going to go over Texas Instruments calculator technology for T-intervals using a TI-84 and a TI-nspire calculator. So the first example, let me just say in general, just as there are calculator applications built in to the TI-84 and TI-nspire calculators for computing z-intervals and z-tests, we have corresponding applications for t-intervals and t-tests, and they look and work the same way. So here we're going to look at a couple of examples using the one sample versions of a t-interval application that's in your calculator if you have one of these calculators. So this is actually the same example that we looked at in the last video. So a researcher wants to determine the average commute time to work in Washington, D.C. He collected the following commute times in minutes from a random sample of all D.C. commuters, and we were asked to construct a 95% confidence interval for the mean commute time of all DC commuters using this particular data. In the last video, we worked out all of the details of that using calculator technology to do things like inverse t and to add, subtract, multiply, and divide, and square roots and things like that, but we did not use the built-in t interval application, and that's what we're going to do as we proceed here. So first thing we have to do, regardless, is determine what type of confidence interval or test is needed and check to see that the conditions needed to use that type of inference are actually satisfied. And we did this in the last video, but let's go over it again here. So notice that we're constructing a confidence interval estimate for the mean of a population. We have a sample size of 32, greater than 30, so the distribution of sample means is approximately normal, and the population standard deviation is unknown. These are exactly the conditions needed for a t interval. The next thing we need to do is we need to get the data actually into our calculator. So if you still have this in from watching the last video, you can skip ahead. But if not, I'd like you to go ahead and put the data into your calculator now. Let's review real fast how to do that. On the TI-84, hit Stat, choose number 1, Edit, put the cursor on L1, press Clear and Enter. That clears out L1, and then you just type all the data in here, 24, Enter, 28, Enter, and so forth till you get to the end. And then do Quit, which is second mode, and that'll get you back to the home screen. In the TI-nspire, make sure you have a spreadsheet a window open or spreadsheet page open in your document. If you need to, press Home and add one. Then type the data into column 1, and I gave it a name, in this case time, and then go back to a calculator page after that. So now here's what we do on a TI-84. We press Stat, left arrow to test, and select number 8, t-interval, select data, and then basically enter it in like it says here, and that's going to compute the confidence interval for us. On the TI-nspire, we're going to select statistics, confidence intervals, t-interval, select data, list as time, confidence level is 0.95, click OK, and that will figure it out for us. So let me go ahead and just illustrate this with the actual calculator here. So first of all, Stat, Edit, I have the data in there on the TI-84. So let's look at that first. Then from the home screen, notice I did Quit to get back to the home screen. Do Stat, it's a test, so the easiest, I can either right arrow twice or left arrow once. And you don't see it here on the t interval here, so we have to go down a little bit. It's number 8. If you knew it was number 8, you could just type 8 without scrolling down, or scroll down and hit Enter. And remember before, or here we want to use data. So we go to Data, and because we actually have the data typed in the calculator. That data is typed in L1, so that's where we put for the list. It's not given as a frequency table, so it's just L1, so frequency is just 1. You put in the confidence level, which in this case is 95%. So I need confidence level to be 0.95. And then calculate, and it comes back with the confidence interval right there, and that does agree with what we had last time. And notice it does go ahead and compute x bar and s sub x and n as well. So it counts the data. It says there are 32 points. It adds them up, divide by 32 to get a mean of 27.21875. And of course it uses the formula for standard deviation. That is, it takes all the x's, subtracts the means, squares those, adds them all up, divides by n minus 1, and then takes the square root. And anyway, it does all that internally and gives you the standard deviation of the sample. And then it uses the formulas for a confidence interval for a t-interval. It does all of it. All of that work is straightforward. It's just programmed right in the calculator, and out pops this confidence interval. Now how slick is that? Isn't that cool? Do the same thing over here on the nspire. Go to Menu, hit Statistics, and then go to Confidence Intervals, and this is a T interval, like that. This is from the data, so that's good, so select OK. Where is the data? It's in the list we called time. What confidence level? 0.95, that's what we wanted, I believe. Yes, and so click OK, and there it is. The confidence interval is right here. There's the lower limit, 23.53 something, and the upper limit, 30.905 something. Here's X bar. This one actually tells you the margin of error as well, and it tells you lots and lots of digits for all this stuff. And the degrees of freedom is 31. Standard deviation of the x's is right here, and n is 32. So it really tells you all the parts of the test that you need. Isn't that pretty slick? So amazing that it's got all that built in. It makes it super easy to do t-intervals actually with the calculator. So let's try another example. See if you can work this one out yourself, and then we can check it with the what I've got going here in just a second. So a random sample of 40 homes from a town were found to have an average value of $92,460 and a standard deviation of $5,200. And their job is to construct a 92% confidence interval for the mean value of all homes in the town. See if you can use your calculator technology to compute this right now. Come back when you finish. Press pause now. Well, first of all, as always, we have to determine the type of inference needed and check the conditions. Notice we're looking for a confidence interval estimate for the mean of a population. Sample size is 40. Since that's greater than 30, we don't have to check normality. We can assume that the distribution of sample means is approximately normal. And notice that standard deviation of the population is unknown. This standard deviation that was given was for the sample. Okay, so this is a one sample t interval. Okay, so let's just go ahead and do that on the calculator here. So let me clear out on the TI-84. I'll do it there first. So we just go to Stat. We go left arrow to Tests. It was number 8, if you remember, for t-interval. This time we're doing it from Summary Statistics, so you hit Stats. And rather than figuring out an X-bar from the data, you actually type in an X-bar value, 29,460. And we type, instead of figuring S from the data, you just type it in. Since somebody's already figured that out for us, n was 40, confidence level this time is 0.92, and then we can calculate. And there we go. The x bar was well, of course, the x bar, s sub x, and n we actually typed in this time. So of course that's nothing new to us. We already knew those three things. But there, look at there at the top. There's our confidence interval. Doing the same thing on the nspire works pretty much the same way. We hit Menu. We do Statistics, we do Confidence Interval, and then we do T-interval. This time, instead of data, we select Statistics, say OK. X bar was 92460, SX was 5200, N was 40, confidence level is 0.92. OK, and there we go. There's the lower limit, upper limit, X bar, margin of error, degrees of freedom, standard deviation, and sample size. Okay, so returning back to our slides here. Here are the screenshots for the TI-84 that you just saw. There are the screenshots for the nspire that we just saw. And here is our statement for our answer. A 92% confidence interval for the mean value of all homes in the town is $91,982 to $93,938. So we are 92% confident that the true mean home value of the whole town is somewhere in this interval. Now, of course, what that means is, remember that the true mean value of all the homes is some number. That's a fixed number. It may change over time, but at this particular snapshot in time, that's a fixed number. So what's happening is we take different samples, random samples of 40 different homes. We're going to construct various different confidence intervals. They would all have the same width. They're all the same confidence level, 92%. They all have the same N of 40. Then they're going to have this same width. What's going to be well, actually, they could have just slightly different widths, actually, come to think of it, because the standard deviation of the samples could vary a little bit. So that could slightly change the widths based on the standard deviations of the samples being a little bit different. But they're also going to mainly vary because of the center of them is going to vary because the X bar that we get each time is going to change. But in any event, we're going to get these various different intervals. If we did this over and over and over and over and over again, we would expect that about 92% of them to capture the true mean, that the true mean would be in them somewhere. And so that's our interpretation. Very, very powerful little application that's already built right there in your calculator that you probably already have, and that you can use that for in my class you can use that for exam problems. Now there will possibly in my class there could possibly be some problems where I might ask you to give more digits than are given here by this one. The only reason I would do that is to maybe force you to go through the formulas and do one of these without the application, just to make sure you understand how it's used. But in real world practice, you're going to use this application because it's usually unlikely that your data is going to be any more accurate enough to make all these digits really that useful anyway. You probably might even round this off even more than it is. So there might be some problems. If you can get the correct answer with just the calculator in my class, hey, go for it. That's what you're going to use. Although I may also set up some things where I force you to go through some of the steps as well. So just be prepared to do that either way for my class.